Hello, am I audible? Can anyone please let me know if I am audible?
Yes, sir.
Yes, sir. You are.
Yes, sir. Yes, sir.
Is my screen visible?
Yes.
Okay,
Yes,
thank you.
yes, sir.
Thank you. So good evening everyone, welcome to this NPTEL live session for the NPTEL course for the NPTEL course Deep Learning IIT Ropar. This is my first live session and my name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So I will conduct my live sessions on every Monday from 6 p.m. to 8 p.m. using this same Google Meet link every Monday from 6 p.m. to 8 p.m. and in these live sessions I will discuss some practice problems related to that week's content. So in this live session I will discuss some practice problems on week 1 content which were mostly introductory things regarding deep learning. And if you have any questions or queries regarding week 1 lectures, you can ask me during this live session. Is my audio fine or is there any problem with my audio? Can you hear me properly?
It is fine.
We can hear you, but there are a lot of background noise.
Yeah, background noise, I mean it is from the ceiling fan, so I can't do anything for that. But if you can properly hear me, then it should be fine. The fan
Yes.
noise would always come, I can't stop that.
Okay, no problem.
Okay. So does anyone have any questions? Or we can start solving some practice problems. Okay, we will start solving some practice problems and then if you have any other questions or queries, you can ask me. So this is the first question. Which of the following is or are applications of deep learning? So there are 4 options: image recognition, text sentiment analysis, image captioning, and D, all of the above. You can write your answers in the chat. Okay, so I've got many answers in the chat. Rakesh, Sushma Shetty, Naveen Roshan, Ajay Sharma, Rahul Mahad, Sri Chaitanya Chadalawada, Rajkumar, Shalini Ninoria, Vemuri Saraswati, Rupesh Shahu, Monisha Das, Vaishnavi, Gayatri, Mohammad Gulzar, Manoj, Dipanjali, Shamagri. Yeah, so all of you were saying option D. So all the answers are option D in the chat, I think. Yes. Yeah. So option D is all of the above. So the correct answer is option D, all of the above. So all these three options, or all these three options are applications of deep learning. Image recognition, so this is certainly a deep learning task, a deep learning application. Text sentiment analysis can also be done using deep learning, and image captioning is also done using deep learning. So all the options are applications of deep learning. So all of you are correct in this question. So moving on to question 2. Which of the following logical functions is not linearly separable? So these are a few logical functions or Boolean functions. Option A is AND, option B is OR, option C is XOR, option D is none of the above. So which of these following logical functions it is not linearly separable? Yes, all of you are saying option C in chat, which is XOR, and XOR is the correct answer. That XOR function is not linearly separable, but and OR functions, these two functions are linearly separable. If we just simply plot these in a 2D plane, we will be able to see that in case of XOR, two positive points are diagonally situated and two negative points are also diagonally situated. So you cannot draw a straight line to separate the positive class from negative class. But in case of and OR, this can easily be done. So if and OR functions are linearly separable, you can find a straight line which can separate positive points from negative points. But in case of XOR, you cannot do that. So correct answer is option C, XOR. Someone is saying I can't see your screen. Is my screen visible?
Yes, sir.
Okay.
Yes, it is.
Okay. Now question 3. Which of the following points are true for McLeod-Pitts neuron model and perceptron model? There are four points regarding these two models, and then you have to find out which of these are true. So point A1 says that inputs are not weighted in MP neurons. MP is McLeod-Pitts neural model. Option 2 says that perceptron model can take weights with respect to the inputs provided. Option point 3 says that MP neuron models process real number inputs as well, and point 4 says that perceptron model process real number inputs as well. So which of these following points are true? So A, B, C, D, 4 options are there. So Rajul, BV, Bhimuri Saraswati, Rakesh, Sukshma Setti, Yas Savarkar, Hanmantlu Surya are all saying D. Kajal Gurnani saying C. No. And Gayatri is saying D. Himadri Nyogi is saying C. Rupesh Sahu is saying D. So most of the answers are option C, but some of you are also saying option D. Any other answers? Anyone else? Samraghi Ghosh is saying in assignment 1 question number 7 I can't solve. Assignment questions we can't solve right now because the deadlines are not over yet. Once the deadline for assignment 1 is over, then I can discuss the solutions for that specific assignment. But I think the assignment deadline is not over yet for assignment 1. So once the assignment deadline is over, then I can discuss those problems. Otherwise it would be unfair if I solve the assignment questions during these live sessions. So the correct answer is option C, which is 1, 2 and 4, these 3 points. So first point says that inputs are not weighted in McCullough-Pitts neurons. So this is right. In McCullough-Pitts neurons, the inputs are simply added up, and if the added up value of all the inputs are greater than equals to a threshold, then it is 1, otherwise it is 0. So it is simply like this. If it is greater than some threshold, then it is y is 1, otherwise y is 0. So these inputs xi's are not weighted, they are just summed up. So inputs are not weighted. And point 2 says that perceptron model can take weights with respect to inputs provided. In perceptron model, this is the from 0 to n. So if this is greater than 0, then y is 1, otherwise y is 0. So these inputs xi's are weighted by these wi values. So these are the weight values. So each input is weighted, so this is correct. So 1 and 2, these two are correct. Point 3 says that MP neuron model process real inputs, so real number inputs, which is not true. So MP neuron models can only process binary inputs. So these xi values must be binary. So this must belong to 0, 1. So MP neurons cannot process real numbered inputs, they can only process binary valued inputs, and so this is not correct. And point 4 says that perceptron model process real inputs as well, which is right. So perceptron models can process both real numbered inputs and binary inputs. So this xi values, these are real numbered inputs, so these belong to a set of real numbers. So 4 is also correct. So 1, 2 and 4, these are the 3 correct options. So some of you have written option D. Is there any doubt regarding this question? This point 3 is not correct. So in that case option C would be the correct answer. Okay, we can move on to question 4. Which of the following statements is true for perceptron learning algorithm? Statement 1 says threshold needs to be hand coded for perceptron learning algorithm, and statement 2 says threshold can be learned by the perceptron learning algorithm. So which of these two statements is true? Option A says statement 1, option B says statement 2, option C says none of the above. So all of you are saying option B in the chat, which is statement 2. The correct answer is option B, statement 2, that the statement threshold can be learned by the perceptron learning algorithm. So if you remember the equation, so if we consider it from I equals 1 to n, and this is greater than equals some threshold, then y is 1. We can simply bring this theta is the threshold. If we bring theta in the left hand side, so this becomes our perceptron learning formulation. So now along with this wi values, theta would also become a parameter of the perceptron learning algorithm, which again becomes learnable. Now if we replace theta as minus theta as w0, so it becomes w0 is called bias. So it would become wixi I equals 0 to n now. So instead of 1 to n, it becomes 0 to n greater than equals 0. So this w0 is the negative of the threshold, which is learned by the perceptron learning algorithm during the training process. Now all the parameters can be learned by the perceptron learning algorithm, so threshold can also be learned. Now question 5. Consider the following McCullough-Pitts neuron unit. This is the McCullough-Pitts neuron unit figure. Identify the Boolean function for which the neuron fires only if the threshold theta equals to 3. So there are 3 inputs, x1, x2, x3, and the output is either 0 or 1 based on the value that the McCullough-Pitts unit compute, and theta is the threshold and it is set to 3. Then which logical function or Boolean function does this McCullough-Pitts neuron unit compute if theta is equals to 3? Options are AND, OR, XOR, and NOR, XOR. Kajal says A, Saraswati says A, Shushma Shetty says and, which is A, Rakesh says A, Samraghi says A, Gayatri says A, Yes, Himadri Raj says A, Ajay Sharma says D, and then Mohit, Deepa, Surya, Shalini, Ninoria says option A. So most of you are saying option A, some of you are also saying option D. Saptarshi says option A. Gauri Ganesh Somasundaram says option B, which is OR. Okay. Any other answers? Does anyone have any other answers? Monisha Das says option B, OR. Okay. So for this question, Macalopitz simply sums up this these inputs x1 plus x2 plus x3, and if it is greater than equals theta, in this case theta is 3, so 3, then y is 1, and if this summation is less than 3, then output is 0. So, and x1, x2, x3, these three are binary valued inputs. So each of these x1, x2, x3 can take either 0 or 1. So in only one case, this the summation of these three variables would be greater than equals 3, which would be when x1 equals 1, x2 equals 1, and x3 equals 1. Only then x1 plus x2 plus x3 would be equals to 3 and output would be 1. In any other case, if one or more of these three variables are 0, in that case the summation would not be able to reach 3, it would be lesser than 3, so output would be 0. So this is the only case when the neuron will fire. Fire basically means the output would be 1. And if you just simply plot the truth table for AND gate using 3 variables, then you will see that output is 1 only when all 3 variables are 1. That is the property of AND gate, that AND gate would output 1 only when all the inputs are 1. So when x1, x2, x3, all these 3 variables are equal to 1, only then AND gate would produce 1. In all other cases, AND gate would produce 0. So this simply is an AND gate, isn't it? Because this MP neuron unit also produces 1 only when all 3 inputs are equal to 1, and in all other cases the summation of x1, x2, x3 would be less than 3, so it would not be able to fire, y would be 0 in that case. So that's why correct answer is AND. So this MP neuron unit produces AND logical function. Some of you have written option B or. So is there any doubt regarding this question? You can ask me. Because AND is when either of these three is 1. In that case the output of OR would be 1. If one or more variables is 1, the output would be 1. OR would produce 0 only when all three variables are 0. So this is not happening in this MP neuron unit. Here for many cases the output would be 0, and only in one case the output would be 1 when all three variables are 1. Okay, if there are no other doubts in this question, we can move on to question 6. So the perceptron given below takes two binary valued inputs, x1, x2, and this is the bias term. Basically -10 is the bias term, where the input is fixed at +1 generally. Which of the following logical functions does it compute? And here threshold is simply 0 for perceptron learning, because we are using bias, so threshold is assumed to be 0. Mohit says in question 4, CTL that W0 is also called the bias. So in this question, yeah, so W0 is the bias in this case, which is -10 here. And if W bias is given, then threshold is 0. That is theta is 0. So which logical functions does it compute? AND, OR, NAND, and none of these. These are the options. And Mandlu Surya says option B, which is OR. Okay. Gayatri says option A. Sushma Shetty says option B. Okay. Himadri Nyogi says option B. Mohit Magwana says B and C both are true. Khalil Abrar says option B. Kajal Gurnani says option B. Rajkumar says option B. Mohit Makwana says option B. Prashanti Mortha says option B. Sweta says option B. So most of you are saying option B. There is some option A answers as well. So for a perceptron, so to compute the output, you have to multiply the weights with the corresponding inputs and also the bias, and then if it is greater than equals 0, then y is 1, otherwise y is 0. So there are two inputs, x1, x2. The w0 is the bias term, which is minus 10 here. So this is simply 20x1 plus 20x2 minus 10 is greater than equals 0. Then y is 1, otherwise y would be 0. And now if we plot the output for this function for different values of x1 and x2, and this is y is the output. So 0 0 1 1 0 1 0. So both the inputs are binary valued inputs already given in this question, 0 comma 1. So for 0 0, the output y would be, so if we plug in the value 0 0 into this equation, we get that it's minus 10, which is not greater than 0. So y would be 0. Now if x2 is 1 and x1 is 0, then it's positive, so it's 1. And if x1 is 1, x2 is 0, still it's positive, it would be 1. And if both x1 and x2 are positive, then 20 plus 20 minus 10, it is positive, so it would be 1. So now this is the output table for this function that this perceptron computes, and it is exactly same as the truth table for OR gate, that if one of these two variables is 1, output would be 1, and if both the output inputs are 1, then also the output is 1. So this is simply the truth table for the OR gate. So this perceptron calculates OR gate. Option B is the correct answer. So is it understandable? Is there any doubt in this question?
Sir, my queries is for any questions like this, we have to check for all 4 combinations.
Yes. So for 0 0 0 1 1 0 1 1, for all 4 combinations, you find out the output for these 4 combinations and check whether that table matches with any of the truth tables of the logical functions, and or not, nor, NAND, any of these functions.
Our rule is always we have to check if it is greater than 0, then output is 1.
Yeah, that is the, in case of any perceptron learning algorithm, the rule is once you plug in the inputs, if it is greater than equals 0, the output is 1, otherwise 0.
Okay, sir. Okay, thank you, sir.
So correct answer is OR gate. Now question 7. Khalil Abrar says, I joined late, will I get recorded version of this class? Yeah, I'm recording this session, so I will also upload it in the YouTube, and later on from NPTEL you will get the links for these recorded lectures. Question 7. Suppose we have a Boolean function with 5 inputs, x1, x2, x3, x4, x5. We have a Macaulay-Pitts neuron with parameter theta equals 1. The parameter is the threshold. Theta is the threshold, which is set to 1. for how many inputs will this MP neuron give output y equals 1? There are 5 inputs, x1 through x5, and the threshold is set to 1. And in case of how many inputs, this neuron will give output y equals 1. Kajal says B, Rakesh says B, so B is option 31. Ajay says 32. Himadri says B, Mohit says B. Surya says A, Rahul says B, Sneha says B, Sushma Setti says 31. Anyone else? So in case of McCullough-Pitts neuron, we sum up the values of the binary inputs, and if it is lesser than the threshold, then y is 0, otherwise y is 1. And if it is greater than equals to theta, y is 1. So there are 5 inputs, x1, x2, x3, x4, x5. So there are 32 possible combinations for the inputs. So out of those 32 possible inputs, only in one case, so theta is theta is 1, so we can replace it by 1. So only in one case this summed up value of the 5 inputs is less than 1, which is when all the 5 inputs are 0. In that case only the x1 plus x2 plus x3 plus x4 plus x5 is equal to 0, and so the summation is less than 1, so it would output y equals 1. In all other cases, output would be greater than equals 1, so output would be y equals 1. So that means apart from the that only one input, which is 0 0 0 0 0, all 5 zeros, in all other 31 cases the output would be y equals 1. So option B is the correct answer. So in 31 inputs, output would be y equals 1. So most of you have written option B in the chat. Now question 8. Consider the data given below. So this is the data, these two are the input features and y is the output level. Is it possible to classify every data point correctly using a perceptron algorithm? So this is the data, and you have to find out whether it is possible to classify each of these 4 data points correctly using a perceptron learning algorithm. Rajkumar says A, which is yes. Sushma Shetty says yes. Rajul says option A. Surya says yes. Himadri says option B, which is no. Kajal says option B. Gayatri says option A. So some of you are saying option A and some of you are saying option B. So the question is it possible to classify every data point correctly using a perceptron learning algorithm from this table? So a perceptron learning algorithm would be able to classify every data point correctly if the classes are linearly separable in the data set. So we just have to check whether these 4 points are linearly separable or not. So there are 2 classes, 1 and 0. So y is the class variable. So we have to simply plot it in a 2D table, 2D plane. So first point is 5 5. Let's say this is the point 5 5. Second point is 0 7. So this is the second point. These two are the positive points, and then the negative points, which is y equals 0 points. First one is 8 0. So let's say this is the 80 point, and let's say this is the -1 point. So this is roughly how it would look if you plot these points in a 2D table, a 2D plane. And we can easily see that there are many possible linear separators that can be used to separate these 2 classes. So this and these 2 points are positive points, and the this one and this one, these 2 points are negative points. So you can use many different linear separators to separate these two. For example, this is one of them. So it is possible to linearly separable these 2 classes, and if the points are linearly separable, then perceptron learning algorithm can correctly classify those data points. So correct answer would be option A, yes. Is there any doubt in this question?
Sir, what's the logic you are using that you say that this is classifiable?
So classifiable means you can classify positive points from negative points, right? So this you have to plot these 4 points. First of all, you have to visually see, otherwise you cannot solve this problem. So you have to plot these 4 points in a 2D plane.
Okay, sir.
So if you plot these 4 points, so this is the first point, this is the second point. These two are y equals 1 points, and this point and this point, these two are y equals 0 points. And if you plot these points in a 2D table, you will be able to see that you can find many straight lines. For example, this one is one straight line which can separate these two classes, isn't it? So positive points are separated from the negative points using the straight line. So this is the linear separator that the perceptron learning algorithm might find. You can find any linear separator that separates these two classes. So it can be one of them. If the classes are linearly separable, then perceptron learning algorithm would be able to classify each data point correctly.
Thank you, sir. Thank you.
Okay. So correct answer is option A. Similarly, now again a data table is given, and you have to find out whether every data point is correctly classifiable using a perceptron learning algorithm or not. The data points are different now, so again you have to plot those data points and check whether it is possible or not. Rahul says B, Sneha says no, Kajal says B, Himadri says B. Okay, so for this problem you have to use the same logic again, that you have to plot these 4 points in a 2D table, 2D plane, and see whether you can find a linear separator for these two classes or not. So if we plot these 4 points, first point is 6, 6, which is a positive point. So let's say this is the 6 point, and then 0, 6 is the second point. This is also a positive point. So 0, 6 would be somewhere here. Third point is 4, 8. So 4, 8 would be somewhere here, and 4, 3 would be somewhere here. So this is very similar to the XOR case, that XOR cannot be we cannot create a perceptron to output the XOR function. It is also a similar case. So the positive points, these two are the positive points, are diagonally situated, and the negative points are also diagonally situated. So you cannot find a single straight line which will be able to classify these two classes. Whether you draw this, it will not be able to classify. If you draw this, still it would not be able to classify. So perceptron will not be able to find a linear separator for this set of points. So perceptron learning algorithm will not be able to correctly classify each data point correctly. So correct answer is no. Now question 10. What is the output of a perceptron with weight vector W equals 1, 5, minus 2 and bias equals minus 1? So this weight vector doesn't contain the bias term. It only contains W1, W2, W3, and this is the bias term, which is W0. When the input is x equals 2, 1, 2, so what should be the output of this perceptron learning algorithm with this weight vector, bias term, and for this input x. Rajkumar says option D. Kajal says option A, Himadri says A, Sneha says A. Shukshma says A. Saptarshi says option D. Mohit says A, Gayatri says A, and Dr. Salini Ninoria says A. Option D. Gangadhara Reddy says option D. Akila Ishwari says option D. Sweta says option D. Okay, so for a perceptron, you have to compute this W1x1 plus W2x2 plus W3x3 plus W0, which is the bias, and if it is greater than equals 0, then output is 1. Otherwise, if it is less than 0, output is sometimes written as 0, sometimes written as -1, depending on the specific task that you are handling. In this case, you simply have to compute this part, W1x1, W2x2, W3x3 plus W0. So if you compute it, it would be 1 into 2 plus 5 into 1 plus -2 into 2 minus 1 is the bias. So this equals 2 plus 5 minus 4 minus 1. So this is 7 minus 5, 2. So this is greater than equals 0. That means output would be 1. So some of you have written option D, possibly because you are computing this 2 as the output, but 2 is not the output of a perceptron. Output is either 1 or 0, depending on whether this computed value Wixi, summation over Wixi, is greater than equals 0 or not. Based on that, the output is either 1 or 0. So this 2 is the intermediate value that you have computed for summation over Wixi, but that is not the output of the perceptron. Output of the perceptron is either 1 or 0. Sometimes it is also 1 or -1, depending on the task. In this case, whether it's 0 or -1, it doesn't really matter, because it is greater than equals 0. So certainly positive class, which is +1, is the output. So option A is the output. When shall we assume 0 and -1 the weighted sum is less than threshold? I don't exactly remember whether 0 was used or -1 was used in the video lectures. I think -1 was used for negative classes in the video lectures for this course. So you can assume -1 to be the negative class. In Perceptron, I think -1 is the negative class. You can check in the video lectures. I think it is given as -1. So in some of the algorithms, 0 is taken as the negative class for easy usage, and some of the algorithms it is -1. So depending on the algorithm, either the negative class is written as 0 or -1. In Perceptron learning algorithm, I think in the video lectures it is given -1. So possibly it would be better you check, if you check in the video lectures. I think it is -1. But in this question, the computed value is 2, which is greater than equals 0. So the output is certainly +1. Now question 11. Which type of neural networks is best suited for sequential data? For example, time series data, text data, audio or speech data, etc. So there are 3 options. This should be A, B, C. These are numbered wrong. So convolutional neural networks or CNN, multilayer perceptrons or MLP, and recurrent neural networks or RNN. Kajal says RNN, Monisha says C, Rahul says C, Akila says RNN, Gayatri says C, Sushma says C, Shaptarsi says C. So the correct answer is option C, recurrent neural networks or RNN is best suited for sequential data like speech data, audio data, text data, time series data. Now question 12. Which type of neural networks is best suited for image recognition tasks? So again, options are same, CNN or convolutional neural networks, multilayer perceptron or MLP, and recurrent neural networks or RNN for image recognition tasks. Akila says CNN, Kajal says CNN, Bemuri Saraswati says A, Dr. Shalini Ninoria says A, Sneha says A, Gayatri says A, Ornita says CNN. So the correct answer is CNN or convolutional neural networks. It is best suited for image data and also for image recognition, image classification tasks. So these were the questions that I wanted to discuss in this live session. Now if you have any other questions or queries, you can ask me.
Sir, question 7, could you please repeat once again?
Question 7. This one. So in McCulloch's neuron, you just have to add all the input variables and check whether it is greater than equals threshold or not. If it is greater than equals threshold, then y is 1. If it is less than the threshold, y is 0, isn't it?
Right.
So it is, and threshold is 1 here. So in only one combination of these inputs, it is possible that the sum is less than this threshold 1. That is, when all these variables are equal to 0, then the sum is equal to 0, isn't it? So in that case, so 0 would be less than 1, so this falls under this case, so y would be 0. In all other cases, it would be greater than equals 1. Even if you get only one variable 1, then the total sum would be greater than or equals to 1 for sure. So then the output would be y equals 1, and there are 32 possible cases, right? Because there are 5 inputs. So out of 32 cases, there is only one case in which it is the output is y equals 0. That is when all the variables are equal to 0. So apart from that case, for all the inputs, the output is 1. So 31 is the number of inputs for which output would be 1.
Okay. Thank you so much, sir.
Okay.
So when will we will get the recorded session of this on YouTube?
You will get it from NPTEL. They would make an announcement in the forum. I will upload it in YouTube, and the links would be provided to NPTEL, and they will share all those links with all of you. When
Yes,
they will
but-
share, I don't know. I mean, it's up to them. I will upload it this video today only, I think, and then after that I will paste the link in the NPTEL sheet. Then after that they will share with all of you. So
Is there any your channel over there so that we will subscribe it, so we will get the notification? Because when the NPTEL will upload, we are not sure about it now.
so you can search my name, Almighty. There you can there might be many such names. So and after I upload this video, then you can search Almighty, and the channel where you see that this recording, you will know that this is the channel.
Can you put your name or the name of the channel in the chat box?
Yeah, my name is visible, I think, here. Almighty. It is already visible in the Google Meet. You can search in the YouTube. There you will get.
On the YouTube, what is your name of the channel?
Channel's name is same. I mean, Almighty. My name is the channel's name. But you will get it in next 2-3 days from NPTEL. So it would not be that much of a problem. They will share in next 3-4 days, I think. All the live sessions are not over yet. 2 more live sessions, I think, would happen. No, only 1 live session is remaining. I think tomorrow there is another TA who would hold another live session. After that, I think they would compile all the links and they will share with all of you. This
Hello.
one.
Can you just tell me where NAND gate will be used?
Where NAND gate will be used
In the Perceptron model?
what will be the weight values for NAND gate?
Yeah. Actually, see, for AND gate and OR gate, we know that truth table. So when we talk about XOR, it is always like you have to combine 2 gates and then you have to get the values.
So NAND, so you have to, I mean,
No, just please give me one example and then explain.
No,
Or
NAND,
even in the expression also it is okay.
no, NAND, you have to first check whether NAND gate is linearly separable or not.
Absolutely yes.
Is it linearly separable? I have not checked it previously.
No, I have a doubt on that. That's what I'm asking.
Okay.
Because there are 2 gates has been combined to it. So how exactly that graph will be drawn, I'm not clear with that.
So NAND gate is AB bar, right? Or is it, and yeah, this is NAND gate. Can you confirm this is the NAND gate? I don't exactly remember.
Whole bar is equal to A bar plus A bar dot B bar. Correct or it is?
A bar dot B bar. I don't think this is NAND gate. NAND gate is you first take the AND of the 2 variables and then take NOT, isn't it?
A plus
Yes,
B
sir.
whole
It will be
bar
whole bar or A bar plus
is
B bar.
equal to A bar
Yeah.
dot B bar.
So yeah, this is the NAND gate, and if you use the De Morgan's formula, I think so.
Yes,
This
yes,
becomes
yes.
this. Yeah, this one. So if AB can be done using perceptron, then AB bar can also be done easily, isn't it? If AB is classifiable, AB is AND gate, it is certainly classifiable using perceptron. Then certainly the complement of that is just the opposite of that, isn't it?
Okay.
So AND gate, in the example I have shown AND gate only, isn't, or OR gate did I show?
No, I am asking you. I'm asking you separately. In case if it has been given, then which option has to be chosen? So I am asking.
I mean, so the question that I discussed was Yeah.
In case if the option is and or NAND and XOR, something like that, the combinations have been given, and then what we have to do with the inputs have been given with relevant to it.
It's, yeah, in any such questions, similar to the question this is the question I discussed. So
okay, you take this question only, sixth question, remove the AND gate, then how this can be solved?
So for any such problems, you have to compute this truth table 0001 1011. You compute this output.
I wanted the same thing to be done for NAND gate. What kind of output?
No, for NAND gate, again I have to first find out these weight values. I don't have the weight values ready for NAND gate.
Okay.
So I have to compute the weight values previously, then I can set up this question. So for any such question, if these weight values are given, for example W1, W2, any W1, W2 values and W0 values are given, you have to compute this table for these values. So you have to compute W1 x1 plus W2 x2 plus W0. If it is greater than or equal to 0, then output is 1, otherwise output is 0. So you compute it for each combination of x1 and x2 values 0, 0, 0, 1, 1, 0, 1, 1, and then check whether this table is similar to the truth table of any of the logical functions, whether it's AND or NAND. In my question it was similar to OR gate. Yes, so this was the truth table I computed, and it is exactly same as the truth table for the OR gate. So you have to, after you compute this table, you compare it with the truth tables of all the logical functions, and then you will be able to say whether it is computing AND gate, OR gate, NAND gate, whatever gate it is computing.
Okay, sir. Thank you.
Yeah. So if there are no other questions, then we can end this live session now. We will meet again next week on Monday from 6 p.m. to 8 p.m. Can we get the PDFs? Yeah, the PDFs should also be uploaded, and you will also get those links of the PDFs along with the video links. So you will get all of these things from NPTEL later on. Okay, thank you everyone for joining.
Thank you, sir. Thank you so much.
Thank you.
Thank you.
Thank you, sir. Can we get the PPT of this slides?
Yeah, PPTs, PDF should also be uploaded. You will also get those links along with the video links. You will also get those PDF links.
Yeah, thank you so much, sir.
Thank you.
Thank you, sir.
Thank you.